next topic. The second topic is the art of creating a performance strategy. And I will give you a short introduction about what is the topic is about. And the speaker for this event will be Samar and Bharat. So what is the art of creating a performance strategy? The performance testing is often seen as a coding intensive exercise, which is dependent on the tool and the code that runs a test. Often in the need to create and run performance tests, the basics of the business need for performance testing is forgotten, both in the approach and as well as in reporting. There are a lot of anti-patterns that we have observed over the years that need to be changed. For example, spending more time on tool and scripting, running tests without understanding the objective of the performance testing and application. The nuances of coming up with the proper strategy based on functional and business need is often bypassed or forgotten. This talk will walk through the basics of creating a perf strategy by looking at the business, technical, monitoring, and reporting requirements to create a proper performance strategy. Deep, will you like to introduce Samar and Bharat?
So now I'll be introducing Samar and Bharat. So today we have two extremely talented, well-known speakers in ThoughtWorks, Samar and Bharat. Samar has been in the software industry for last 16 years. He has worked extensively as quality engineer in different product and services organization. In the past, he has worked as DevOps and Scrum Master as well. Currently, he's playing the lead QA role in ThoughtWorks. He loves to solve problem using technology and process. And now Bharat. Bharat Kumar is a principal consultant and has been working for over 16 years in the software industry in various roles, from that of a developer to IT head of a real estate company. He loves to look at technology with a business mindset and solve real world problems using technology. Currently, the ops lead for the data and AI service line in India.
I don't know who wrote that. That sounds too braggy.
It's okay, Bharat. We know you are being modest.
Okay, folks, let's get started. Okay, able to see my screen now, right?
Yeah, we can see.
Bharat.
Are we audible? Completely audible?
Yeah, completely audible.
Yeah, audible.
Okay, awesome. Cool. Ready to get started, or should we wait till 6? No, for people joining in that sense.
Can
Yeah,
start.
we can start.
Yeah.
Cool. Awesome. So thanks, guys. Thanks for the wonderful introduction and the synopsis of what we are planning to do as well. So you've just taken out 5 minutes of my speech by giving that synopsis. Thank you very much for that. So we can probably dive right into the perf part of it then. Cool. So thanks, guys, for joining us today. So I thought we'd probably start with why we wanted to present on this. So Samar and I have been doing performance testing in our recent engagements for a bit. And we've kind of been going back and forth on various topics in the performance testing field. And we got to talking about various things that we've observed of late when we talk to people who have been asking us questions about performance testing or things around how to go about doing performance testing and things like that. And we noted with some dismay that the first thing that people think about when you talk about performance testing is just some scripting that you do at the end of your integration testing or your proper functional testing before your project goes live, right? So it is typically thought of as a tool-based activity where you create a bunch of scripts that emulate a workflow or a critical workflow, and just keep increasing load, decreasing load, run it for a specific amount of time, just look at the response time and make sure that you get to a certain throughput in terms of the number of requests or data that is being sent to your end system, and just sign off on whether your product is good to go or not, right? So that kind of brought us to thinking that, hey, maybe the reasons for why people do performance testing may not be very well understood, in the industry as a whole, right? It's seen more of as an afterthought maybe because maybe because it's difficult to do, or maybe because it's not understood as well, right? We talked about the tooling process. We talked about looking at perf only running critical parts of your functional test, for example, and also looking at it as a scripting exercise, not even as a coding exercise, right? I think I'd like to make that differentiation between scripting and coding. So scripting is something that you create a temporary code that runs against something, whereas coding is something you craft, you create a well-designed piece of code that can be maintained, that can be extended, and that can be that you can do something with, right? So all of this leads to people not really putting the thought to create a performance strategy. So we decided to create this presentation to share some of our thoughts on some of the things that we've seen, on what people are not doing well, and maybe what are some things that have worked for us in the past. So before we get started, right, I think it's a good good place to start is to understand what is performance testing and why do people really do it, right? So I think, as I said, the commonly understood theme about what performance testing is that it is, a test of your application versus load, right? It basically is a bunch of virtual users you keep running against your system. And as you keep increasing, you look at the response time and the throughput. Maybe you look at the resource usage and you get back to your team and say, all done, right? So you're not really considering the fact that performance testing actually came about as a way to look at infrastructure, right? It wasn't about looking at scalability at all in the beginning, scalability in terms of handling multiple users. So maybe I'm revealing my age over here, but when we started performance testing way back, it was more to see whether the infrastructure that we could run against was able to handle the application that was being hosted on it, right? So we would look at, deploying the application that we were planning to use, and web was pretty new at that time. No, I'm not 90s old, but at least, a decade later. But even a decade later, after the 90s, people were still looking at hosting the application and trying to look at how many people can actually use it. And thousands of users or X number of users were never a priority. It was more about looking at resource usage, CPU usage, memory usage, disk, IO, and things like that. And capacity planning was more around what this was used for. Then it kind of eventually went into the part where we look at the web, where we look at having multiple users, different types of users, different locales of users, different users on networks that are completely different from one another, etc. Right? But ultimately, you can kind of boil down performance testing, if you look at it from a macro level, into three main components. It's basically a test of time, where you're improving time, where you're looking at time consumption, etc. It's a test of the cost that you're going to incur to your client or to your application. And it is a test of experience that your application is giving. So you could put it as quality, you could put it as experience, you put what name you want to on it. But basically, you can boil it down to these three main attributes according to which this gets done. And who are the people that really do this? We'll talk a little bit more in detail. Samar will go into that a little bit more in detail going forward. But basically, it is your business. So it primarily came about as a business way of handling what your application is planning to do. Right? So if you really think about performance, it's actually a measure of all these various abilities. Now, this is not a comprehensive list of all the abilities that you can look at when you are testing an application, but these are some of the ones that we felt were very important, when we are testing a typical application. So you obviously look at response time, you look at responsiveness, which is how does the application under test react when you're interacting with it. You look at, the availability of the application, how long does it stay up? How reliable is it? And reliability is basically, does it give you back the same result when you do a particular action on it, which is supposed to give you back the result? You look at resource usage, you look at the throughput, you look at the time consumption, etc. And stability, scalability, and error handling. The thing is that not all of these are equal in nature, right? So depending on the type of technology, the architecture, or whatever program you're planning to test, all of these take different levels of priorities. So for a typical application, if you take an interface application, your AIs, your your UIs, your APIs, etc., you would be worried about the ones in blue a little bit more, or you should be worried about the ones in blue a little bit more than the other attributes, for example. However, if you were to look at perhaps a non-AI application or non-UI application, like an IoT application based on networked devices, for example, your priorities shift a little bit, where you're looking more at things which are around the scalability, the availability and reliability of your system, because you don't necessarily have an interface to interact with it. Similarly, if you take a look at a typical AI application, let's take a chatbot, for example, right? You might not be so worried about the response time and the resource usage because the application by itself might not be as heavy. But you do have to worry about things like your error handling, your responsiveness, the availability and reliability, especially compared to just the plain response time of your system. So not to say that none of these are important. The response time is important and becomes unusable if it is beyond a certain threshold. But what we're saying is that these are perhaps things that are important to you as well. And the reason for pointing this out is because it is very important for you to understand that different systems, different technologies require a different approach. And hence, we come to a performance strategy, right? And, I'll turn it over to Samar, who will talk through what does a performance strategy really mean? What does it look like? And, please go ahead, Samar.
Thanks, Bharat. Okay, so a performance strategy looks like considering of these items. That's what it is. Like you need to have all these components in your strategy document, but it can also differ how your application is designed, what is the purpose of it. But basic structure, yeah, this is what it is, and we'll go deep dive into it. The first thing is the factors. Factor which is mix of your business and technological. And that will determine your direction, where exactly your performance strategy should be designed and around it, and who are the stakeholders who will help you to get this information. And also you need to make sure the interest of the stakeholders are fulfilled during your test, and that should reflect in your test strategy. So let's take one by one. The first one is the market analysis or the research data. Suppose you are building a new application, right? You won't have much idea how the application would perform in the market. That's where your marketing team comes with some research, that how the projection of the application would be. Normally, we talk about the year-to-year growth of the app, but if you go deeper into those reports, they have eventually broken into multiple parts. Suppose if it is a application on e-commerce, there is a projection is that we are expecting so many users in the first 6 months on cart, then out of them, few will go to checkout, and of course, it will reduction will happen when you go to the final transaction or the order happens. So this will help you to create your train of test on those data, because that is the only basis you have. That is the basis your business is getting planned. So your performance tests also have this input and something you have to rely on. Now, considering this is on an assumption, but that's how your your market team or the business is going to get built on. Now, the second aspect is your application usage. What is the application about? What is the usage pattern? Whom we are expecting? E-commerce can have a billing, and there is also an option that e-commerce platform may not have billing. For example, a regular checkout in an e-commerce, probably you are choosing a product, you are checking out, and there is a billing option. You have to pay by credit card or any other means of payment. However, another also there's a grocery shopping option is available where you have a wallet already attached to it, and you just add item and automatically every day it will detect it. Basically, the daily grocery shops app goes through that process. So they don't use the the credit card option where you check out for each and item, that's not needed. So you need to know what is the application usage, and accordingly, that will help you to start the finding the flows around it. Now you need to know the user workflow. The user workflow and the application type will determine your path. For example, let's take this cart workflow. So it might have multiple pages. It will have a cart, then there is a checkout, the shipping. So everything comes into a picture. These are your points which need to be added into your script, and also that also how much of the percentage of the user will be go in each page. So that data will come from user workflow. Now consider e-commerce flow. We'll just use that in an e-commerce for a regular where you buy your clothing or apparels. The per day traffic would be really big, right? Now compare to another e-commerce portal which sells some exclusive best of the best luxurious cars, maybe 500 to 600 cars per year. The experience would be very different. It would be a lot more rich on your UI compared to any other e-commerce portal. So yes, your users are different. The workflow also will differ. Probably you would have heard about single page checkout as well. So that's why you need to know the user workflow and how it is structured around. Next is the data interaction. That's where you need your architect diagram and the data flow diagram as well. That will tell you what are the data interaction point we have, how much item we are going to store, what are the storage option you have, and what point. So this will help you to understand the volume of data you are going to deal with. Also, that will also give a direction whether you need a volume testing or not, and what are the other performance type of testing is needed. Let's talk about the constraint and dependencies. I'm again going back to the architecture because I feel that is one of the key point when you start on a performance test strategy. If you notice, this is a very typical diagram of an e-commerce portal where it has a backend, there is a PIM, which is basically product information, and there is something called billing is there. If you notice in Purview, this called something email service. Now consider which is within this isolated area is belong to a single team. So suppose you are going to test this out, you have understanding to these teams or these components that you are going to send a load, and this will be tested throughout. Now consider this portion. This is the email service. Maybe this is how it is something you are consuming a service from outside or a third-party service. So when you are doing a performance test, maybe they are not ready. Or if you're paying for it, your regular test, probably that would be very expensive. So that's kind of a constraint. And you are also dependent that you cannot go away with this because probably your code is tightly coupled that whenever any change is happening on a transaction, an email notification will go. So in this scenario, you have to think about whether you can go with a mock. In case you are going with a mock, you have to work with your partner team that what is the SLA they have. For example, if it's a sync process, if the response within 1 second or 3 seconds, 4 seconds, they would have done their performance test. So you need to have an agreement on that, and accordingly you have to create mod exactly in that. So you have to use delays, whatever, if you are using wire mock or mount back, you have to exactly replicate the same thing. Now, other dependencies would be, suppose, let's take off PIM. Now PIM has this component, maybe it is not attached to their performance environment. It's a very small unit which they just for QA, not for performance. So in that section, you have to again restructure whether you can test without this PIM. So these are the constraint and dependencies you have. You have to work with your partner teams and third-party partners you have to maintain how this strategy would be. In terms of to handle this, it is always to do over communication. Over communication in performance tests is very much essential, and you should not shy away from it. Other dependencies could be your organization level freeze periods. A lot of organizations do not allow performance test in certain period of the year. And also there is some structure to it, like it needs some approval. Make sure you are aware of it before getting started. I would even suggest, while scripting, even Bharat is going to cover that, you should be aware of what do and do not of the organization, and then only you should start working on performance test. Okay, next is analytics and traffic. You would see it is wow, it is different from the first point. So this is for the some of the legacy product or product, something which already existing, and you want to start a performance test for it. Here your best friend would be your something like, if you have a Splunk or anything which will give you the data from last 1 or 2 years, that will tell you which is the most busiest or most peak hour of a second within last 1 or 2 year data what you have. Similarly, you can get it from your Adobe Catalyst, or if you are using good Google Analytics, that will also give you these data. That would be probably your starting point. For example, if I see this is the most peak time, and probably my starting point would be that if I can load this and I see my performance, how it getting started, that should be your starting point, because your system is already are getting this load. So eventually in future, as business grows, you'll only grow from here. And again, performance testing we don't do for tomorrow or day after tomorrow. It is kind of a long-term plan. You always plan for something like 5 to 6 months or even a year, depending on the projection with your marketing team. Okay, now we have find out the factors. Let's talk of the people or the stakeholders in your performance test. They play a big role. What we have seen from last couple of slides, the information is always not about you. You get from multiple folks. So who are they? It is the product owner who drives complete the program. They'll tell you whom to get, what to get, and who most of the information comes from the product owner. Then DevOps, who handles your servers, your infrastructure, and probably the most people who are close to the numbers regarding your server side. The next is the architect or the development team. They will tell you in terms of how the product is designed, what are the constraints of the product in terms of the stack, the tech stack what we have. Then finally is the business and domain specialists. So these are the folks basically who have understanding in terms of how the ground regarding that the application you are building on, how the business looks like. And also they connect with the architect and dev regularly. So probably they have both the business as the tech. So they can give you a lot more insight to it, and probably your best friend when you have the results out. Bharat will definitely go over that and tell you on negotiation part. So creating a performance load, you got the information for stakeholder, you got what need to be done. Now what you need to follow to get started with your load design, or basically the scripting part. So basically the identification of actual user and prioritizing most expected journey. In an e-commerce portal, I'm just going back so that everybody can understand. Okay, let's take out for e-commerce as well as a medical record. For e-commerce, it is the most used flow is getting started with the item, finding the item, then adding the cart, then checkout and transaction. There are other flows are also there where you can check your order status, and also going to my account, so where you can see your orders. However, you need to find out where exactly you are expecting more traffic. That's where your analytics or your marketing team is going to help you out, and you will find which is the most appropriate area to get started with your first set of test. For medical record, it could be the registration and also the consultation. But if it is about finding daily reports or some medication, it can differ. Again, it is up to the analytics from the marketing team where they feel there will be more traffic coming in. Then the entry of user on exit, that it is basically where which part of your system where a user enters and what are the information they bring in, and when they are exiting the system, what are the changes it is making to your application. So you need to take encounter of each. Coming to test data, it is kind of expected. Like we always expected the test data is something like look like completely to production data. but due to security and privacy, it is not always advisable to bring your production data, because we don't want to use production or the user data just for testing, because that's not the way it's supposed to be done. So analyze the data, create appropriate synthetic data so which can be used. And the idea is to create the test data pattern as much as possible close to production. Otherwise, you will see a very different numbers to what you have done in your performance test. Also, if you are creating data in your test in the script, make sure it is dynamic. You are not using any static data, because that's how it's supposed to be. Then tools and monitoring. So there are a lot of tools out there, and we are going to see a couple of them, what they bring in, and what are the pros and cons they have. But you need to identify which is applicable to you, not about what team is aware or what you are aware. There are a lot of tools. They comes with a lot more benefits, and eventually every day there is some tools are coming in. But find out which is going to help you out. It's not about load tool again, it is about also monitoring. You are doing certain tests, but what exactly it is replicating on your servers or even on a client side, that need to get monitored. You need monitoring something on real time so that you can take appropriate actions. Next is the load or concurrency. How many users are there? How many concurrent users are there at a certain second? Those things, something will help you to design your test. The final is environment. It is always advisable that you need to have a isolated performance environment. Why isolation? Imagine you are having a test of 10,000 user. They are doing some heavy transactions. At the same time, other team is also doing some testing. So obviously your test data is going to get corrupted, or somebody is started deploying something in between. So it will go down for couple of minutes or second, depending on the structure you have. So that's the reason we don't advise to run your performance test on dev or a QA environment, which is mostly for functional and test out the initial set of code. Having a performance environment which is almost replica of your production is something you should go for. In case you don't have, then you can work with your partner teams so that you can isolate a couple of hours just for performance tests. So nobody should use that. Also, it depends on what is the capacity of your performance environment. For example, in production, you might have suppose 4 cluster machines, and you in your lower environment or performance environment, you have 2. So in that case, you have to reduce your load accordingly. You have to do a lot of math. And in case in your architecture, if you have something, out of 4, there is one is called admin, which do more extensive some batch process or something. You have to do something in the performance as well. The math probably will go a little complex, but it cannot be the same load what you have planned for, as in production. Okay, so let's take a look at a type of performance. It's not just about load, it is actually more. So what we look for in a performance test, it is responsiveness, stability, resource usage, and scalability and reliability. So under the actual load test, right, various load tests, that's why you look for the most responsiveness and stability. Then it comes to the heavy load or peak load, right? The intention is to test it something like 3x or 5x test, where basically you are taking a point where you basically going to a breaking point of a system. You understand, after this my system will break, and you want to put a heavy load and see how your system is behaving against it. So next is the soak test. Basically it's a long run test. You kind of put different load, and you can run for a longer period and see how your system is behaving to it. Reason, like in an e-commerce portal probably it does not run for half an hour, 15 minutes like a load test, right? It runs for 7-8 hours. You see a big load, then slowly it comes down. So you want to replicate that. Configuration test. Now these are really important. This is probably you'll do more once your first set of load test is done. Configuration is nothing about all the tech component what you're using, that comes with a optimization of configuration. So you want to change those configuration and see whether this optimization is really reflecting on your test. So you need to make those configuration changes, and you are trying with different loads. Then comes the spike, where like a ramp up, like in a soak or even stress testing, here you are immediately giving a very high load and see how your system is behaving. Is it taking a load, or is it putting some certain users into in a wait time? Those things something you need to look at. The final is the volume test. So in volume test, it's not about responsiveness, it is more about stability, and how efficiently your resource are getting used is something you would look at. It is about something heavy data, which is basically storing comes in. Basically, if you have a database, if you are sending a lot of data, how it is reacting. Is it able to absorb all the data? Is it able to do the transaction in both way? Basically, it is able to serve, as it is able to write new set of data, or able to write, update it. Those things, something you want to take a look at it. Okay, so what we gathered so far, if I put in a table for a summary view, that's how it looks like. We measure the response time. We check the resource usage, basically your CPU, memory usage on server side. The failure rate, there are certain failures that we expect, especially we are going for the soak test or the sudden traffic test. But you need to have an agreement with your team, like what is the failure rate we should have. Is it 2%? It is 5%, which actually that is around 3 to 5%. That is kind of expected. But again, it depends on how intensive for your application to have that failure rate. Then throughput, it is common across. It is like how much the load is per second your system is going to receive. Then load and concurrency. What is the environment, the infra capacity we're testing with? Is it same as production, or it is kind of scaled down version of it? Then how many virtual users we are going to have, and how it is going to, the traffic pattern would be. The load breakdown. So on each transaction, on which part where you have maximum load, how the reduction will happen on next stage, or it will go up. That load breakdown need to take into your consideration. The load scenarios. What are the scenarios you want to test it out? For example, maybe a checkout of a product, and taking a production status or the order status, because once you purchase, you want to see how it is, how soon it is going to arrive. And reporting. Reporting, as we spoke about, it is the logging of data. Again, it is not logging of the how your JUnit, JMeter or any other tool is giving the logs. It is also how your server logs are getting generated, and getting any live report out of it. Then report template, a report template which is kind of understandable to all the stakeholders. It is also advisable to, if you can create this report template much early and include in our test strategy discussion, so that everybody agrees that this is how your report is going to look like. Data store. Now performance test is something you need to repeat even for the first cut of set, right? In a functional test, suppose you are testing something, you test it out, you say okay, test pass. But in performance tests, we repeat a lot. Even the first set of load tests, if you're doing, probably you'll do this 30-minute test, right? Or even 15-minute test. You need to repeat it multiple times. Why we do that? Because you need to see whether the pattern is same or it is differing. Or if it is differing, is there any factor or dependency what we have? So that's the reason you need to store this data. Whether it is going to be in an Excel sheet, that also you need to say, okay, we are going to store here. This is how it would be. You need to create a format of it. Or a better would be a Grafana version, because you are chunking the data in, and you can see how after all the configuration change or code change, you see it is coming down, or there is a reduction. It is a very good way of presenting out, and that is how it is. You store the data, you can create a visualization out of it, so that you can show your growth in performance, or what are the effort you have put to optimize the performance. You can see that. All right, so we need tools for monitoring. The first comes the application performance monitoring. This is where you put a tool where you can see how your servers are behaving. Imagine a scenario, you push something like 10,000 users, they are doing transaction, no error. But if you're not monitoring, your CPU could be running around 85-90% already. Now, if you're going to a market and your product goes really well, the moment it goes to 12,000, probably your CPU will go out of power and you will see the errors coming out and it will crash. It has happened. A lot of e-commerce portal has crashed. Lot of other portal has crashed because of the infra could not support. So that's the reason you need to have a watch on your CPU. Also, we have this auto cluster mechanism in Google Cloud or even in premises as well. You need to know what is your breakpoint, that after I reach 80%, it takes another 2 minutes to get loaded, so that new clusters start being responsive. So you need to understand it is the extra 2,000 or 3,000 when you get into what is the time gap I'm getting. So maybe we need to say that, that will help you to auto cluster mechanism, which will say after maybe 60%, you'll start clustering, rolling out new machines in. All this data will come from this. So it will tell you the memory usage, the network usage, how much transaction you are doing with your DB. That also helps you when you have the first set of results out and you notice certain transaction is slow. Where you will see the visualization where I'm getting the slowness. It is where this New Relic or App Dynamics is going to help you out. They will tell you if on this transaction, you can identify the transaction, where it got delayed. Is it on network? It is on the application layer, or when it got to in DB, this is where I'm spending. It can pinpoint to exact the query where it is taking time, and you just need to optimize the query and you can see the change later on. If you notice, CloudWatch is there for Amazon. It is very exclusive for Amazon. It has some basics one with free. So you can utilize that as well. But New Relic, Dynatrace, or Dynamics, they have a lot more feature in actually. Okay, we got the cover for our server health. Next is the server or the application log. Now, application log, you would say, okay, no, I'm getting the response time in my JMeter or Gatling. Why need this? See, you'll get the most purest form of your response time within your server. It does not look where you are sending your request, whether you are sending your request from a 1 Mbps connection or 100 Mbps connection, or if my server is in US, whether I'm sending the load from Singapore or US or somewhere in Bay Area. So the response time won't will vary in your client side or basically where you are running your JMeter or Gatling, but in server, it will respond as it is. Another point of your benefit, if you have a log monitoring, is that suppose you send total 1,000 requests. What if your server just got only 800? How would you identify, or that if you just look into your Gatling's result or something, you'll see, okay, my all 1,000 has gone in. I saw some response, there are some errors. But it is your logs will say that, I have received 800. That's where you can verify, you can validate and match both. You can get a lot of information. There are a lot of errors comes in during the performances, which you can see here. None of the other tools can help you out here. So make sure you have good monitoring tool, but only monitoring tool won't help you. You need to have good monitoring logging as well. So you need to work with your developers to see all the logs are getting, chunked out to these tools. Okay, finally, this is what we always think performances, but this is the only part, Okay, so we got all these tools. You would have heard about these tools. You would have gone through a lot of demos. You would have tried your hand. Each comes with their own benefit. JMeter is there from, it's like a long, like more than decade. It is there from long time. To be honest, tools have matured a lot. They're like beyond JMeter. There is Gatling is there now. Locus and K6 are really doing great. Something code as script. It has so much possibilities around. You can see how popular they are in terms of the GitHub stars itself, because JMeter is there for a long time. But what brings JMeter is the support for the protocols. Currently, others are probably not doing it. So that's why probably the big gun of JMeter is still there. It is still people are loving it, and it is still live there. But again, if it is on HTTP, HTTPS, yes, there are better options are available. Because JMeter is very resource hungry. You cannot spin out number of virtual users like others are doing in JMeter. So choose which is applicable for you. You can take a look at this screen, see where you want to try out your hand, check with your team where you have more expertise to handle this, and then you can take a decision. Okay, so far we have covered almost the purpose, stakeholder, goals, tools we noticed, then we found how workflows to be converted to your workload, then types of tests what we know. It's not just about load testing, it has so much variation, and you need to see which is applicable for you. Tools we noticed. So execution, reporting, insight. Bharat, you can take it over from here.
Sure. So before we proceed, just a quick couple of questions to be answered. So I've answered one, probably in like very short form, but see, test data creation is a separate topic by itself. Actually, we did not go too much into detail because we can actually talk about test data creation and manipulation and maintenance for a complete 2 hours by itself, right? But to be very succinct in terms of what are some typical strategies that people use to create test data. And again, this needs to be a joint effort, right? This is not just on the people who are doing performance testing. This involves BAs, this involves folks who are from the product team or from the domain team, everyone, right? All of these people are equally important to the creation of test data. So all of these folks have to determine what is the best strategy to use and what is the most optimal strategy given the resources at hand, both from a money perspective, people perspective, etc. So please keep all of these things in mind when you're talking about test data or creating test data. But a very typical way of creating and maintaining test data is to reuse existing production data for running systems, right? Or to use similar data from existing systems. So if you are creating an e-commerce application, there are many tools that are available that can give you production-like data, right? These are not synthetic data. They are actually data that can be bought from people who are actually using this, right? So it would have a complete end-to-end, scenario in terms of, your starting point to your endpoint. And there are different types of data available for different domains. So you can choose to buy it. You can choose to use existing production data. The the problem with using existing production data is that there are perhaps many legal concerns involved. The legal teams might come and say, hey, you cannot use our existing customer data. We're supposed to be anonymous. We're supposed to do all of that. So a lot of the data that you need to use may need to be anonymized, may need to be changed completely, which becomes an exercise in creating synthetic data anyway, right? Because you are anonymizing a lot of the data that you might need to use. The second strategy, of course, Samar mentioned as well, is creating synthetic data. Now, depending on the size of data that you're planning to create, 5,000 users is not a very big number. So creating for 5,000 users, there are many tools available, free tools available that can give you the data that you need just by creating this. You can even write a test script. So I like Python, so I can use Python libraries to just generate anonymous data for me, right? Or random data for me. So you can use a lot of the random generators, UUIDs. You can use name generators. There are a lot of modules that are available in different languages that can help you create production like data. So looking at some of those modules would be helpful if you're going down the synthetic data route. However, if your data is very complex, very domain dependent, you might need to use a paid tool for it, which could be pretty costly. Again, that is something that you need to work with your product owner, with your folks to determine whether it is worth creating all of these things for you, right? So that is why, this is very important. A third way is to create dynamic data, but this should almost never be an option used unless your data is very small, right? Unless it is data that can just be created on the fly. So that is something that is a very important thing for you to do. So I think Bridge has also shared something. So maybe you can take a look at his blog at what you can do with test data as well. Please do get in touch with us if you have any more questions regarding this. We'd love to share any of our expertise or thoughts on these as well. As far as the second question, if you have 1,000 users that are just passive users in your system, you can add noise to any test. That is part of your workload design. So your main test, so you could structure these as two different tests while you're running one test to just run the background where there are users just just doing some random things that are not associated with your data or the test itself, and just have that running on a constant basis. And then you have another test which is your actual test, depending on the type of test that you want to run, whether it's a spike test, a load test, blah blah. And you can do it that way, or you can build workloads in your singular test as well. I think I would prefer the second way of doing it, because you can run multiple tests without affecting the background load. But the way that you structure the test could be based on how you would design that particular test itself, right? The third thing, maybe Samar, you can take that, whether it is a good, whether it is good to use user profiling or JMH tests.
User profiling, right? So
Yes.
user profiling could, I think, from my experience, I work most closely with the business owners or the business actually to get how the user pattern would be. Let's take an example of a medical record. I'll just go back to the same one. In a consultation, right? How many fields a doctor kind of uses or adds to the customer or patient profile. In that case, probably the business or the PO, they know, right? Because they interact with the user. So I can ask, how or what kind of a data is getting inserted in that time. So you have to pattern your user profiling accordingly. That is one. Second thing is, what about the silent data, or which is in a database? How much data would be there, or patient information would be there? In that case, again, you have to see which day of your adoption you are looking at. For example, if it is an e-commerce portal, the first test could be your first 15 days, where you are starting from 0 to 15. But you are expecting that after 2 or 3 months, I will have so many users, so many transactions. Those things, probably your backend, you need to use some script, load it across. So you'll see, okay, out of, suppose I have 5,000 total users, and when I'm testing, there are 100 users are active. I'm just giving a user or a profile view how you will design it. That answer? Or we can take it up since we are.
Yeah, maybe we can answer some of these towards the end. So just in the interest of time, let's just go through the rest of this presentation, so that we don't make other people wait too long as well. It's pretty late in the evening. Cool. So we talked a lot about the tools and stuff like that. So whether you're doing front end, back end, whatever kind of performance testing you're doing, you're going to be using similar tools. So your exact same tools that you're using for your API testing can be used for your front end as well. So it depends on what you're doing from a front end testing part. So if you're talking about loading an application through the UI URL only, that usually does not happen. So when you load a URL, you will notice that there are a bunch of other things that get loaded. So typically, you would call the main things that would basically call that would simulate the URL call. So maybe we can get into it towards the end in terms of how you would do performance testing for the front end, but it is not very different from a typical API testing as well, right? So the same exact tools that you would use for front end are easily applicable for the back end also. All right. So in terms of, we've talked about tools for monitoring, tools for all of that. Now we come down to the part where we're talking about coding or scripting the actual test itself, right? And what I said in the beginning. So, this performance coding or performance testing is considered to be more of a scripting exercise, where you create a bunch of scripts which run based on the tool that you use, and it would do those things, and you kind of forget about it once you're done with that. But that is kind of the complete opposite of what you should be doing. Writing a performance code is the same as, your code itself. It should be well maintained. It should be well structured and organized. It needs to follow the same principles that you would use when you are creating, code to create function in your project, right? So please do make sure that your code is well organized and structured. And what I mean by that is that when you look at the structure of your project, it should be clear what are the files that you would take a look at for the actual simulation that you're running itself. The part where you're, specifying the number of users, the kind of activities that you're running on the test, how long those need to run, how long they need to loop, all those kind of things, right? So those are simulation files. So simulation files should be well removed from the files that are actually doing your activity, right? So when I say activity, performing your request, getting back your response, parsing your data, all of those should be structured in a way where you should be able to look at each separately and understand the entire flow of what you're trying to do. Doing this makes your test readable, makes your test extensible, and trust me, it makes it extremely maintainable. So if somebody new were to come in and run what you have already created, it makes a world of difference for them if you are able to, craft your code properly, right? Another thing that I've always noticed is that people treat it like temporary code. So it's filled with hard-coded data. In fact, people even put complete request blocks in the data in your files themselves. This should not be done, right? So like I said, all these activities need to be done separately. All the data that can be changed or will change or can have different values should be parameterized, should be pulled separately away from your code, so that anytime you need to make a change, anytime you're trying to change the data, these activities become very easy. Because when you think about a typical performance test, if it goes well, you will be asked to run the same performance test on the same system in a different country, for example, if you take any application, modern application nowadays, right? Or you might be asked to test it in a different environment completely. So making sure that you parameterize all the parts that can change is very important for you. So please bring in your best coding practices to the performance code as well. Please make sure that you use design patterns, and there are a lot of design patterns that are very useful when you're coding your applications. Uh, Please use the factory, the singleton, the decorator pattern, the builder pattern. The builder pattern is very, very useful, especially when you're trying to break down your application into different parts, right? Uh, I would love to elaborate on those, but unfortunately, we cannot get into too much detail as far as all of these design patterns. Please do read up on these and see how they are useful. Maybe Samar and I can create a GitHub repository that talks a little bit or gives examples of these design patterns. Perhaps we will do that in the near future. But please do read up on these design patterns and see where these can be used. Another big anti-pattern that I've noticed in the code in the past is that people rarely create performance tests for debugging, right? So when the test set is running, it is almost impossible for anyone to figure out where their code is breaking, how their code is breaking, kind of pinpoint what are the areas that could be causing issues in the run itself, right? So make sure that there is proper reporting and debugging built into the code that you create. Please use a third-party tool, reporting tool, if the tool that you used does not have a very good reporting report. For example, Allure is a great report to use. Depending on the kind of software that you use, like Gatling, for example, creates a brilliant test report. However, other tools are a little bit more basic. Like JMeter's reports are not great, Locus reports are not great, but you can always combine many other tools that are available for free or that are open source along with your code to make sure that these are done in a much better way. It also kind of prevents you from spending too much time in creating a nice report that can be packaged and given to other folks as well. So please make sure that all of these things are done. So one thing that we wanted to kind of touch upon, so Samar and I were talking about this in terms of How applicable is CI/CD to performance, right? It's not that you should not be doing performance testing with CI/CD, or you should always be doing CI/CD with performance testing. The answer to this is always going to be that it really depends on what you're trying to do. If you're doing shift left performance testing, where you're running small performance tests and kind of trying to benchmark your dev code as you keep creating it, please do incorporate it in CI/CD. If you are very confident that that your perf test will only be run after a certain maturity of the code, please use CI/CD. However, in general, at least both of us have found that running CI/CD consistently across performance becomes a big pain. It's not that it cannot be done or should not be done. It's just that the amount of effort that you put into creating a pipeline, maintaining that pipeline, and maintaining that load going forward is a lot of trouble, right? So it becomes a very objective decision or subjective decision on your part, depending on which situation that you're in. If it is an easy exercise to do and something that you see brings value to your running it, because for example, using a GitLab, if you create a CI/CD pipeline for your performance test, I found it that it's very easy for anybody to come and run a perf test, right? Any user can come and run it. They're not dependent on one particular individual to fire up the test, run the test, report the results, etc. However, maintaining this pipeline was a pain, because if anything changed, something would break in the CI/CD pipeline. So getting this entire process running together was a lot more effort than maybe the results that we were getting. So please do keep this in mind when you are trying to figure out whether we should be doing CI/CD with perf testing or not. All right, so now we'll talk a little bit about execution, some best practices. So we talked about one where if you want to run passive users, you can run it as a separate workload or a separate test. Start it well before your actual test and then run your test itself. I hope that answered that question. If not, please do put that on here again, and we can try to examine that in more detail at the end. In terms of your typical results, right? You need to run your tests and you need to look for a certain set of metrics. And these metrics kind of help you measure your test to see whether what you're doing makes sense or not. And ultimately, tie back to the business objectives or goals that were set for your performance testing. A typical tool will give you the results that you see on your screen, right? So you will have a number of activities. Those activities will run a certain number of times, and the rest of it will primarily be related to your, your times, the response times that come back. You usually have an average and a median, which are great to see, but pretty useless in terms of actually looking at how to measure something consistently. What is perhaps more useful are your 90 percentiles and your 90 percentile timing in terms of response times. So these are very, very good at looking at how your system is behaving as a whole. 5% is usually a good amount of variance to use to discount for anomalies in your a network, in your security, all those kind of things. So usually a 90 or 95 percentile time is a good one to report. And tracking these two metrics is a great way for you to look at how is the response time in my test behaving. These are usually based on industry standards. For a front-end system, 2 seconds is usually a good time or a very good time for what you're seeing on your screen load up. For an API, it could be as low as 50 milliseconds if it's or 10 milliseconds if it's something that is feeding into a bigger API. Or it could be 300 milliseconds for a large API that is providing aggregated data from multiple APIs, for example. The error rate is very important. Anything more than 4 or 5% should cause alarms for you. And this is why your debugging also is very important, because you should be able to separate what is an error that is caused by your script. And there can be many times errors caused by your script by incomplete headers, or there could be authentication issues, or many other issues that could cause problems, right? So discounting that 4 or 5%, it is usually good to take a look at the error rate. Anything more than that should be considered a fail. Your throughput would be based on your workload design. So please concentrate on your workload design, because that is what would drive here. If your response time and anything else is great, but your throughput is not increasing beyond a certain amount, that shows problems with your infrastructure. So you might need to talk to your DevOps folks, talk to the product owner to see whether the infrastructure that you're using is capable of supporting the application that you have. So all of these metrics are things that you should be constantly looking at, creating a trend analysis for, and basically benchmarking against. So you would initially create a benchmark and then see if it is meeting it, exceeding it, or getting better. The problem would be if you keep seeing upward trend without any significant benefit from what you're seeing over here. Can you go to the next one? All right, so we talked about resource usage also as a big category of metrics to look at. So typically these are looked at by your APMs, so your application monitoring software, and all projects have them nowadays. This is what a typical cloud APM would look like for a cluster of pods, which are running a bunch of services. Your CPU utilization, memory utilization are perhaps the key ones that you would always be looking at. And anytime these cross a threshold where you see the CPU being pegged at 90 to 100%, or your memory constantly going up without coming down, are clear indicators of performance issues, right? So your memory utilization never coming down shows memory leaks. Your CPU utilization being pegged constantly shows that your infra might not be capable of supporting your current load. So you might need to scale your infra, right? Your disk usage might show an excess of IO writes or reads. So that might need to be looked at. So these are things that you would look at not just in isolation, but in combination with your response time and various things. Oftentimes your answers to the problems that you're seeing in terms of response time and things like that can be answered just by looking at your response, your resource usage. But otherwise, you do need to go into more intrusive tools like Dynatrace and stuff like that, which are able to look at things from a coding perspective. Another thing that you really should be doing is working with the dev team to look at the logs and see whether you are able to create a profile for the entire request that is being sent or response that is being sent back. Do they have timers at multiple levels, which are able to give you the data that you need to create a complete package in terms of this is my request, this is my response, and this is how different elements are spending time on it. Ultimately, this is what the devs would need to do anyway. So if you guys can get the devs to put in those timers and logging, in the beginning, nothing like it. And those should be dynamic so that when they actually deploy to production, you can maybe put them under some kind of toggle, which makes sure that they get turned on whenever you need to run it in debug mode and turned off whenever you're running it in production mode, for example. But they should always be there in that. So now we talked a little bit about the reports and stuff that we generate, right? But what do we really do with this? What is the purpose of all of this stuff, right? So like we said right in the beginning, the purpose is to solve some business problem or answer some business question. The money, the time, or the quality or experience related aspects of it, right? So depending on what kind of goals and objectives you had, I've kind of broken it down into three main ones. If you're doing, capacity planning, you need to help answer questions around infrastructure. Is the current infrastructure good enough? Do we need to scale up, scale down? Do we need to increase the amount of resources that are available to the application, right? Is the current configuration optimal? So you have configurations at the network level, at the security level, at the backend, which is a database or some kind of backend level. All of these have configurations that need looking into, right? And all of these are things that need to be constantly tested. They also help with future planning of the system. So if the system is planning to grow X percentage over the next 6 months, 1 year, how ready are you guys to take on that growth, for example? If you are just running it as a way to highlight performance issues, bottlenecks, etc., please compare against benchmarks, but do not forget to renegotiate or redo the benchmarks if it is not possible. These are conversations that people should be having with business, saying that, hey, you guys are expecting so much data to be sent up and down, and there is no way that we can meet the 300 millisecond benchmark that you have kept for us. Either reduce the amount of work that needs to be done, or we need to look at new times over here. So these are things that people often do not renegotiate with the teams because they wait too long, or they do not even inform the business stakeholders that these are things that need to be done, for example, right? Of course, identify bottlenecks, identify issues, and these are done with good logging, good amount of investigation into what are the reasons for these metrics that you're seeing with poor, times or resource usage percentages, etc. Right? Uh, Please do look at creating different types of tests, not just a singular critical path test, but maybe multiple tests which have multiple configurations, multiple users, different types of data, large data, small data, etc., to be able to give a complete holistic picture of what is it that you're trying to do over there. A lot of times I see teams only running one critical path, which leads to many, many issues going forward. So that is another thing. So the third type of testing that you might do is kind of related to capacity planning, but something that you should be doing on a constant basis, which is to enable cost optimization by saying this is the best infrastructure that you can use for it. Move forward, Saman. Right. So these are just some quick metrics or a combination of metrics that you can use as a small explanation for these. So please do look over them when the decks are shared, or if they are kept in some common place for these. So quickly, like to summarize what we've really tried to do in this particular discussion. So we've tried to say that, performance of the system is more than just its response time or the resource usage, right? And that the goals and the objectives that you are specifying right at the beginning should be done in conjunction, not just with, the devs or the tech lead, but also with the business stakeholders. And that this should be an activity that is done well before you write a single line of code or think about, what are the scenarios or whatever you need to do, right? So please create a strategy which lets you think about the entire performance process as a whole. And, another thing that you need to do is you need to make sure that all of these objectives or all of these things that we are talking about are done before you start scripting, because what we have always seen is that people new to performance testing always get started writing code without even worrying about what is it that they're trying to do. But, most importantly, what we really want to stress is that, Samar and I are like the best QA testers ever, and we want you to agree to this. No questions asked. So yeah, so that is the end of our talk, right? We can attempt to answer some of the questions that are there. So, Samar, you want to go for the first one?
I think just few things like at the end of the slide, we kind of captured the summary, and there is a a reference guide, or this open source project Bamni. There is a performance strategy. If you want to take a look at how a test strategy should look like, you can take a look at it. So, all right. So let me stop sharing and Q&A. Let me take a look at it. Okay. Is it a good idea to advise the team use profiling or just identify performance bottleneck earlier in the development? Yes, the more early you start, you'll get a more better starting point. And also during the architect discussion, right? You can get a little bit idea, where exactly your performance testing can be prioritized. When tested at the system level would be actually reduce the performance bug. Yes, I think as you notice, it's a combination of things. Like if you have a little bit of buggy application but strong hardware, it takes away. However, considering right now everybody is moving to cloud, the optimal resource or the system usage is the key. That's the reason you'll notice a lot of capacity testings are happening, because we want to find out what is the best system or the hardware where your cost optimization would help. You can also do your costing calculation. There is a AWS provides some tools, and you can see with so much network and also your testing results, which is where you can save your money. So that is one of the area, in fact, where a lot of AWS consultant are making a lot of their career go high. So that is one more point as a performance tester, plus how to do the calculation cost. So that is one area. what is load breaking? I assume, Bharat, if you want to get into for the load
I've only
breaking.
heard of load breaking in an electrical system, and I've never heard of it in performance testing. So I'm not
I think
sure.
it is determining the breaking point where your initial the errors start flying in. Yes, so there is a method where you can increase your number of users and transactions, and you'll notice certain where you see the first failure coming
I
in.
think he meant load breakdown. So load breakdown
Okay,
basically
I thought
could
the
mean a
breaking.
couple of things. Load breakdown could be the number of transactions that you need to put into the system. So for example, if you are talking about a typical e-commerce system, your load breakdown would be how many users do you need to have in your system over a period of time, how many peak users, how many concurrent users do you need to have running a particular topic. And these can further be broken down into the types of users or the types of activities that you're currently doing. So let's say 100 users are just hitting the login page, 50 users are going to the cart page, 10 users are going to a product detail page, stuff like that, right? So a load breakdown would kind of talk about all of these different things.
Yeah. The typical mistake, probably I will also admit, something I would have done, like, 100 users coming and doing the purchase. It does not happen. That never happens. Most of the QA does the first performances. That's what they do. They kind of load users. Everyone does the same transaction, but that's not realistic. You will get some numbers, but it will be very different from what you see in production.
And determining the value of the performance metric, this always has to be done with business because they are the ones who are determining whether what you are doing is good enough or not. However, there are certain industry benchmarks. For example, 2 seconds is considered to be a great metric for a page load. 300 milliseconds is usually the time that you would look at for a large API, for example. Querying times from databases depends on the size of the data or the format of the data and all of that. So all of these things vary. And sometimes you might need to do an investigation into the appropriate time given the infrastructure that you do have as well, right? The second part of the question is, how do you make sure validation you're doing in the script is proper? That I don't know how to answer that. So if you are validating validation is different for different things. So if you're validating data, you need to validate whether what you're getting back is what you're expecting. It could be the format that you're looking for. It could be the values that you're looking for. It could be the content that you're looking for in case of a document itself, for example. So that the way that you do it is typically through assertions. I don't know of any other validation, or you could have, templates for larger data sizes stored, for example, which you could compare against your data that you're getting back as a response or something, in case there's too many things to compare. So those are all different things that you might want to look at.
Yeah, I think Bharat, you touched upon a very good point, how much assertion we should do. What my point is that we do a lot of assertion this in your functional test. Here you need to probably do some assertion on your response code, not than the response body. So you need to make sure, when you ask your load tool to do a lot of assertion, you also utilizing or reducing the load capability. So since if you have validated something in your functional tests, you can reduce a lot of assertion. How you make sure validation of scripts? Okay, if I'm sure that my assertion, everything is fine, what I do, I start with very minimal test load, like maybe 2-3 users, and I see total funnel. Total funnel is how my load test is behaving. All assertion, everything is fine. Logs I can see. Then I go to CPU usage and see whether it is spiking. It won't spike a lot, but it little bit. And I'm seeing the log of the trace. I can trace a single transaction across. What Bharat mentioned that can you identify one transaction complete entry and exit point completely? That's what I do. That's how I debug my code. There is one point regarding the TPS. I think that is one of the key points, right? My manager or tech lead says that just go and load this API. That's it. Do you test our functional test without acceptance? We don't do that, right? This is our acceptance. It should meet at this SLA. We should able to handle this many users. That is your acceptance. If you're not having these acceptance criteria or from stakeholder information, you just don't do functional testing, how you can start your performance testing? So ask for your SLAs. These are something. If tomorrow somebody asks you that, test this out, just load it and tomorrow we need to release it, ask these questions, or else it is like, you just blindfolding and going into a dark room. I think there is a ask for a blog. To be honest, I'm not that great in blogging, but I have given the one link is there in the deck. It is maybe you can search in Bamni performance test. This is a wiki. This is somewhere we have contributed. That's a product which is live. That's a pure performance test. Something you can take a look at it. Again, it's a completely for the Bamni product, but you can take a template out of it.
Okay. People, please remember to share your feedback in the form, as it would help us to grow. I think no more questions now. Thank you, Vishal, Brajendra, Samar, and Bharat. We appreciate you making time in your busy schedule for the wonderful talk and insights on the topic. And thank you, attendees, for making this session interactive by asking more questions. I think that is the end for us.
Thank you.
Thanks, guys.
Thanks, everyone.
Everyone.
Bye-bye.